Thank you, Josh. And thank you all for being patient here tonight. I ran back home, which is not too far away, thinking that I would be able to find my little dongle thing for my Macintosh. And of course, I didn't need to do that, as it turned out. But as I came back, I was thinking, well, maybe I could be liberated by not having a PowerPoint, and I could just tell you some of the ideas that I have. But for better or for worse, I've got some PowerPoint slides to share with you tonight that hopefully can help tell a story about the challenges we face in communicating the science of climate change and related topics. When Jeannie Scott, who I think a lot of you know, first suggested that I give a talk here, she suggested a title like Skeptical View of Climate Change Skeptics. And the word skeptics, I think, in this context of climate is problematic because there's a group of people who have kind of taken hold of the mantle of authentic skepticism and used it to really deny the robust science behind climate change. And I'll get into some of the nuances and details of that in a few minutes. But I think another subtitle or another way to think of this is a alternative title, Confronting the Doubt, Delay, and Denial that have prevented us from having an adult conversation about climate and energy. And I think a lot of you know that for the past 25 years or more, we've had a real struggle in this country, much more so than other countries, to really talk about the science relating to how humans are impacting the environment in general and climate in particular, and also our reliance on fossil fuels. I think some of you may have seen that clip from the Daily Show where he showed every president going back to Richard Nixon talking about how we need to have energy independence, how we need to get off of fossil fuels. And of course, we've been saying that for, since the Nixon years. And meanwhile, our consumption of fossil fuels just keeps going up. There's a fellow named Donald Brown who has a project at Penn State called Climate Ethics, climateethics.org. And he makes it very clear that skepticism is the oxygen and catalyst of science. And without it, as you all know better than most people, science just doesn't really have the chops. It doesn't have the inquiry and the dialogue and the authentic debate. But one of the points he makes is that deliberate misinformation about climate science is not real skepticism. And that moreover, free speech, when people use free speech as a excuse for, in some cases, propagating lies about climate science, that is morally reprehensible. And in the cases of corporations, he says it's particularly loathsome. But I think Donald Brown comes from a perspective that climate change is essentially an ethical issue. The bulk of climate change is being caused, at least in the near term, on the wealthy people, the affluent people in the world, the 1 billion or so major emitters. And they're impacting people around the world, not just today, but into the future, who don't have much leverage. They don't have a voice. They don't have any, at this point, real legal challenge or standing. And their only hope is that those of us who are responsible stand up for our responsibility and do what we can to reduce our impacts and prepare society, including the global society, for the changes that are already well underway. Human beings have become a force of nature. There's just no question about this. And we'll focus mostly tonight on climate change. But we, as a human entity, move more dirt around the planet than all natural forces combined. We fix more oxygen than all the bacteria on the planet. We are, without a question, a force of nature. And there's a new framework that over the past couple of years has been presented called planetary boundaries. And they focus on the fact that yes, it's not just CO2 changing the composition of the atmosphere. We're also altering the nitrogen and phosphorus cycles largely through the manufacturing and use of fertilizers on a massive scale. Ocean acidification is happening. Of course, that's tied with CO2 going into the atmosphere, because about 30% of the CO2 that goes in the atmosphere ends up in the ocean. There's chemical pollution, and we're only beginning to get a handle on things like endocrine disruption from the soup of chemicals that we flush away from our factories, from our cities, and you know, sewage treatment plants treat some amount of pollution, but they can't deal with this toxic soup that ends up impacting the sexual reproduction of all sorts of organisms. And on and on. I mean, clearly we've impacted the ozone layer. Fresh water is being impacted and depleted, and that can be tied to climate change. Likewise with land use and the way we've changed land use that's affected biodiversity. So there's absolutely no question that we're a force of nature. And again, this is a conversation that we rarely have as a society to talk about these incredible impacts that we're having. When I was growing up, the main impact we were concerned about in terms of humans and the environment was thermonuclear warfare. And I think some of you are of the age that you remember the duck and cover drills and the building bomb shelters and all the like. You know, this is still a serious concern that we just don't talk about because it's, on some level, we're sort of in denial about it, but we talk about it in proxy terms. We talk about it in terms of Iran. We can't let Iran get the bomb. But meanwhile, one of my colleagues, Alan Robach, who's at Rutgers, but actually on sabbatical here in the Bay Area, I ran into him down at San Jose State recently, and he's been taking a fresh look at nuclear winter and just the dynamics of that, which I think a lot of you are familiar with, of how even a fairly modest nuclear exchange is going to burn cities. If there's ground bursts, a lot of dust is going to be created. There's certainly going to be a lot of smoke from the burning of the cities. Sunlight is going to be absorbed and reflected. And the bottom line is that very little sunlight is going to reach the ground after a thermonuclear exchange, and the surface temperature is going to drop very dramatically. And of course, we generally call this nuclear winter. This is a concept that was put forth in the 1980s, and the papers that came out on nuclear winter helped motivate Gorbachev to start to de-escalate that arms race that Reagan had initiated, and they did reduce some of the nuclear weapons on the planet. But still today, there's many thousands of nuclear weapons, and this is just a scenario of what would happen if India and Pakistan exchanged weapons. There would be a very abrupt climate change as a result of just a war between India and Pakistan, and that would be a temporary solution to climate change. But unfortunately, of course, we have a lot of dystopian science fiction novels. Maybe even The Hunger Games is kind of coming out of a post-nuclear winter situation. But if there was even a higher exchange, because again, Russia and the U.S. have combined many thousands of nuclear weapons, that could even create a much more abrupt and long-lasting impact on the climate system. So the work of Alan is based on climate research and related research that
Nice work, Pablo. That was the warning siren.
Okay. Yeah. Duck and cover, everybody. Just joking. So there is climate science itself goes back nearly 200 years. This fellow, Jean-Baptiste Joseph Fourier, was really a brilliant scientist in the early 1800s, and he had a pretty solid handle on the basic dynamics of the Earth's energy balance, the incoming energy from the sun, the outgoing energy from the Earth after it's been warmed by the sun, but he didn't have enough data to understand why the Earth is warmer than it should be. And he posed that to the next generation of scientists, and John Tyndall was one of those scientists who kind of picked up the ball with this question of why is the Earth warmer than it should be, and he ran with the ball, and he understood this imbalance and wondered why that was. So he started looking at the gases in the atmosphere to understand maybe one of those gases is trapping some of that outgoing heat, the infrared long wave heat. So these guys were smart. When people say, oh, climate science is new, they don't really know what they're talking about, it's simply not the case. The climate science goes back well over 150 years. And John Tyndall's work in a small little laboratory where he set up kind of a miniature atmosphere was some of the seminal work that still has set the stage for how we understand the climate system in general and the greenhouse effect in particular. So he did sort of process of elimination. He knew that the atmosphere was made up mostly of nitrogen and oxygen, free oxygen, and argon, and there were also some trace gases. He knew water vapor and CO2 were some of these gases that didn't make up a large amount of the overall composition, but through a process of elimination, he knew that nitrogen and oxygen and argon did not capture that outgoing infrared heat, but CO2 and water vapor did. And he published that in the 1870s, although the work he did was actually earlier than that, in the 1850s. This guy was quite a character. There's a Richard Somerville, who's a scientist from Scripps down in San Diego, has done a really fascinating kind of bio summary of John Tyndall, talking about what a great science communicator he was. He was also kind of a showman. He loved to get up in front of a stage with a bunch of beakers and mix things together. But he was really quite a fantastic science communicator. He was also a contemporary of Charles Darwin. The two of them met on quite a number of occasions and exchanged letters. So they were very much contemporaries. And actually Darwin was really fascinated by some of Tyndall's studies of glaciers in the Alps, trying to better understand some of those geophysical properties, geophysical processes that Tyndall was studying. So a generation after John Tyndall, Svante Arrhenius, who was a Swedish chemist, I think some of you may know him because he was the one who came up with the concept of pH, which is one of the fundaments of chemistry. He knew that when you burned coal, and they were burning a lot of coal in Northern Europe and in England back in the late 1800s, he knew you released what in those days they called carbonic acid into the air. Now we call it CO2. And so he, knowing that this is a heat-trapping gas from the work that John Tyndall did, he did some mathematical calculations. This is all by hand, by the way. There were no handy-dandy calculators, let alone computers to do these calculations. So it was in effect a hand-drawn mathematical model of what would happen over time if we doubled the amount of carbon dioxide or carbonic acid in the atmosphere. And he estimated that there would be about a 4-degree Celsius rise in temperature and as much as 8% in some of the northern latitudes. And I think remarkably that's very close to what modern day models are saying in terms of a doubling of CO2. Well, fast forward 50 years, and there was actually a lot of research that went on and a lot of debate and skepticism about what Arrhenius was proposing. There's another fellow, Guy Callender, after that who started to try to pull together climate records from around the world. But we'll fast forward to the International Geophysical Year, 50 years after Arrhenius published his paper on how human beings could alter the the climate and warm the planet by burning coal. So this is the International Geophysical Year, IGY. I think a lot of you are familiar with it. Some of you may even have remembered it from weekly reader newsletters in your school, or maybe some of the movies that came out back in the day. But the National Academy of Sciences published a number of these beautiful posters, which are in a lot of places like NCAR and up at the University of Colorado in the halls of the National Academies and so forth. These were actually part of a science education program for IGY, and they were around the themes of the International Geophysical Year, which, by the way, was during the middle of the Cold War. They were doing atomic testing of hydrogen bombs in Nevada and Algeria and Siberia and so forth. So it was a very intense point of history, but Soviet scientists, American scientists, and many scientists from around the world were collaborating on trying to understand the planet better. And one of the themes was weather and climate. And the National Academies published a little book called Planet Earth, The Mystery with 100,000 Clues. And by the way, you can still get these posters and the little booklet through the National Academy's website. But the little booklet is a wonderful little artifact from back in the day of IGY science. And I think it really planted the seed for a lot of the scientists that came of age in the 60s and 70s. But in the chapter on weather and climate, where they're talking about human impacts on the greenhouse effect, they mention the fact that our industrial civilization has been pouring carbon dioxide into the atmosphere at a great rate. By the year 2000, we will have added 70% more carbon dioxide to the atmosphere. If it remained, it would have a marked warming effect on the Earth's climate, but most of it would probably be absorbed by the oceans. Actually, we now know 30 to 40% of it is absorbed by the oceans, not most of it. Conceivably, however, it could cause significant melting of the great ice caps and raise sea levels. You can also find on YouTube videos that were made, like the Bell Science Hour from 1958, where they're essentially saying exactly the same thing. This idea that we could change the planet by burning fossil fuels was not lost on this advertisement from Humble Oil, related nowadays to, it was eventually absorbed by ExxonMobil over the years. But Humble in Life magazine was bragging about the fact that they've supplied enough energy to melt 70 million tons of glacier every day. Go team. There were a lot of reports that came out over those intervening years. In 1971, MIT and the Swedish Royal Academy put out a report on inadvertent climate modification. The Charney Report, a really famous report from 1979, talked about how a doubling of CO2 will likely result in a rise of 2 to 3.5 degrees Celsius, with larger increases in the higher latitudes. And over the past 50 years, I mean, this is for those of you in the back of the room, I know this is impossible to read, but it's basically 1900 to 2000 with all these exponential curves, in population on the bottom, fossil fuels, the black kind of going on a very steep curve, GDP sort of in tandem with the fossil fuels, because as we burn fossil fuels, let's admit it, our standard of living goes up, and we're able to drive cars and fly in airplanes and have cold beer and hot showers and all the rest of it. Meanwhile, CO2 is going up as well. So there's certainly a lot of indicators of this warming, and I think you all have heard about the fact that the various temperatures are going up, humidity is going up, sea ice is going down, glaciers are going down. MIT, who I mentioned a second ago, did a report in 1971. They just came out with a report on energy and climate for the next century, basically projecting that the Earth's population will probably peak at about 10 billion by 2100. Our world GDP will really continue to rise, and especially in the other G20 nations and to some degree in the rest of the world. But as a result, because that GDP is so closely tied to fossil fuel burning, we could hit the equivalent of 1,200 parts per million of CO2. The CO2 itself may be about 800 or so, but when you factor in the other greenhouse gases and their CO2 equivalency, 1,200, which would be 3 times what it is now. And that has enormous implications for how much the temperature could rise over the coming century. And that depends on how sensitive the climate system is. You know, when people talk about debates, you know, within the climate community, the debate is not about whether it's happening or not, whether there's warming happening or not, or whether humans are responsible. The debates are about, are we going to have low climate sensitivity or high climate sensitivity? Should we be preparing for 2 feet of sea level rise or 6 feet of sea level rise? And those are the types of debates that are actually happening, despite what you tend to hear in the media. So, what is the sort of the lay of the land, so to speak, in terms of trying to move forward towards a more adult conversation about all this? We have a number of different folks that are really interested in the topic of climate for different reasons. We have folks who have taken the label of climate skeptics, and this is kind of a tongue-in-cheek look at how they think of themselves. The climate analysts would be more the climate scientists who really don't have a lot of regard for the climate skeptics, but at the same time they sometimes think of the climate advocates who don't really know the scientists as you know, really being uninformed and kind of crybabies about the whole thing. But in any event, the situation is really, shall we say, dysfunctional. And here we have a pie chart from the New York Times showing that the large majority of people believe in global warming. Some don't believe in global warming, and there's a fraction of people that don't believe in pie charts. But the situation actually is that, and this is a nice little graphic from Kathy Zhang, who points out the fact that it's so hard to change the status quo. And the status quo, by and large, around the world is reliance on cheap fossil fuels to grow your GDP. And the people that say, whether they're scientists or advocates who say, let's do something about this, let's have an adult conversation about it, they're pushing, it's an uphill battle. I mean, this is sort of the classic Sisyphus dilemma. You're dealing with gravity here, and it's easy for somebody to put their finger up or just the sort of the gravity of the situation to say no. And why is that? Some of you, I'm sure, are familiar with the 6 Americas framework, where they've done these sort of audience segments of people around the country and their attitudes around climate. It ranges from those who are alarmed to those who are dismissive. And I'll come back to this in a minute. But it is a bit of a bell curve, although the bell curve is tilted more towards those who think climate change is happening and that probably something should be done about it. Those of you familiar with the work that NCSE has done around defending the teaching of evolution know that there's these 3 pillars that are often used to try to promote teaching alternatives to evolution, specifically creationism and more recently intelligent design. And those 3 pillars are essentially that the science is bad, it's wrong, that there's an ideology that is threatened by the science. In other words, the science is going to have bad outcomes for society, and that as a fair culture, we need to hear from both sides. We need equal time so that the story of evolution can be heard side by side with the story of creationism. The idea of climate change can be told side by side with the idea that climate change isn't happening and humans aren't responsible. So those pillars play out in creationism, that evolution is weak, and that evolution and religion are really incompatible. So it's only fair that the two be taught side by side. With evolution, of course, it's illegal to teach religious concepts in a public school. So that's a leverage that we've had for a number of years to be able to prevent this sort of teaching both sides idea of evolution. With climate change, it's trickier because we don't have any kind of legal precedent here. But the same types of excuses are used. The climate is weak. The climate science is weak. It's actually very anti-capitalist. It's a UN conspiracy to destroy America. I'm sure a lot of you have heard these types of rationales. And therefore, teachers should teach both sides to avoid dogma, to avoid turning our kids into liberal activists or whatever, and to promote critical thinking. And of course, it's that critical thinking piece that's the trickiest, because that sounds like good skepticism. But again, it can be a way that they get their foot in the door to perpetuate confusion and debate where there really is no debate. So this is a famous quote from Luntz back in the early 2000s, where he says that the main goal of those who are trying to prevent an adult conversation around climate change is to accentuate the uncertainties, to continue to make the lack of scientific certainty the primary issue in the debate. They've been doing this for over 25 years, and they continue to do it. They've been extremely effective at doing this. And they'll use the idea that this is healthy skepticism to continue this approach. Just to be clear, the part of the lay of the landscape, and this ties in with the Six Americas segments, is that the people who are promoting anti-evolution agendas overlap a little bit with those who are promoting anti-climate change agendas. They're both conservatives, and the ones who are most interested in anti-evolution are the religious right conservatives. There are, obviously, as you know, many religions that have embraced evolution, have no problem with it, and the NCSE has, this Voices of Evolution project that has helped identify all these religious organizations. And likewise, there's many religious organizations who have made strong statements about the importance of dealing with climate change. But as I say, the ideology focusing on climate change is much more libertarian, free market deregulation, and they don't like the implications of dealing with climate change. This is from the Six Americas study from a couple of years back, showing that the alarmed, by and large, are not identified as born again or evangelical, whereas the dismissive are more so. But still, that's only roughly 50-some% of those who are dismissive have a religious connection, and many others do not. But there are instances where the religious right have been anti-climate change because they say it's part of this environmental cult that is trying to steal our children away, trying to brainwash our children, and create a world government. It's going to be devastating for the world's poor. So they have a whole series of videos that you can buy called Resisting the Green Dragon. And some of those clips are available for you online if you're interested in checking that out. Likewise, the folks who are intent on stopping a conversation about climate change have their own websites. The Heartland Institute is one of the more prominent. There's a website called globalwarming.org where they talk about maybe it's a problem, maybe not, maybe humans are responsible, maybe not. But we don't want to spend all that money on it, and that sort of cuts to the chase. Senator James Imhoff was on TV. He's got a new book out about how climate change is a hoax, And he admitted that he thought climate change was probably pretty serious until he realized how much money it would cost to actually deal with it, which was kind of a revealing statement. But even groups like this are starting to admit that, well, they're hedging their bets. They're saying, well, maybe it actually could be happening, and maybe we should do something about it. So I think that's an interesting change that's happened just in the past year or so, where a lot of these libertarian think tanks are starting to admit that, yes, humans have some responsibility, and CO2 plays a role in that, but it's going to cost too much to deal with, and CO2 is good for plants, and et cetera, et cetera. So what is the role in education in all of this? And I just have a few more slides here to try to just focus in on some of the challenges of dealing with climate change in educational environments. The science is complex. Often it hasn't been taught at all. It falls through disciplinary cracks and curricular cracks. It has not been well coordinated. It has not been well addressed in standards, whether it's state standards or national standards. And of course, there's this political polarization that lead a lot of good teachers, not knowing any better, to teach both sides because they think it's fair and balanced. And we see that again and again, even with teachers who say that they understand climate change is happening, but it's really unfortunate that that's happening to such a degree, and that's just part of the challenge that we face here. That is in some ways really different from fighting against those who wanted to teach creationism in the schools. There's also a very strong emotional dimension to all this, and one of the reasons that people have said don't teach our kids about climate change or teach the other side is that they say our kids are coming home depressed and they're upset, and you're freaking our kids out, so we don't want that. So again, this is part of the mix that makes it so difficult. So there's been a number of these academic freedom bills. One was just passed in Tennessee yesterday. The governor did not sign the bill that the House and Senate passed, but by not signing it and not vetoing it, it became law. And essentially what this law does is it allows teachers cover, it provides cover for teachers to teach both sides, it's essentially really unnecessary, and it leads to confusion. And the bottom line is that it undermines solid science teaching. There's lots of materials out there. Unstoppable Solar Cycles is a very popular DVD, and it's available through YouTube and that sort of thing. And people like the Heartland Institute, the video, The Great Global Warming Swindle, came out a few years ago, and that's still being used in classrooms as sort of the counterbalance to an inconvenient truth. But I think we can also be really informed by some of the work of the sociology community. Stanley Cohen wrote a book called States of Denial, where he talks about 3 key kinds of denial, and we see this in climate change all over the place. Literal denial, it's just not happening. Interpretive denial, well, it's happening, but it's cosmic rays, or it's something else, it's not human activities. And then the final, in a way, the most difficult form of denial is denying the implications and the responsibility. And Carrie Norgard, who's at the University of Oregon, a sociologist, who has a book out called Living in Denial, where she looked at a village in Norway. Norway's very affluent country, a lot of oil and gas money. They consider themselves to be very environmental. They don't have a disinformation machine like we have in this country. They don't have a lot of so-called climate skeptics at all. And yet, people are not really doing anything about climate change. They're not doing anything to reduce their carbon footprint as a society. And so what she's observed is what she calls social numbing and motivated avoidance, where people just don't talk about it. They avoid the topic, even though the ski areas have no snow in the winter. So the way she frames it is that climate change is common knowledge, but it's also unimaginable. And of course, another way that we've dealt with this topic as a society is through cynicism and satire. This is a Diesel Jeans ad from a couple years ago where they were using global warming as sort of an ad campaign. So there is good news, and I'll close with some things that I think are really actually very positive and could make a difference over the coming years. And one of them is the development of the climate literacy framework, which has been reviewed and endorsed by the U.S. Global Change Research Program, which is made up of 14 federal agencies, including everything from the Department of State and the EPA to the Department of Defense and the Department of Interior and on and on. So climate literacy was really well vetted, and it's very authoritative, and it's been used in a lot of curriculum development programs. We also pestered the Department of Energy to develop or to take the lead on energy literacy, which just came out very recently. And these are both online through the globalchange.gov website. If any of you are interested, I do have a couple paper copies I can show you later if you're interested. So there's been a number of curriculum development projects. One of them is CLEAN, the Climate Literacy Energy Awareness Network, which has over 400 high-quality learning resources that have been vetted to make sure they're scientifically accurate and current, and that they're good resources to use in a classroom or other learning environment. And then a local project, the Alliance for Climate Education, based here in Oakland, has actually reached over 1 million students around the country through school assemblies. They're doing some really exciting work to motivate young people, to give them some of the tools they need to start to have a conversation among themselves and with their parents and their communities. So that's very positive news. And then finally, the National Research Council came up with a new framework for K-12 education, and those are being transformed into the next generation science standards. Those are coming out very soon. Global change and especially climate change are very well handled, we feel, in these new standards. 26 states, including Tennessee, by the way, are part of this next generation project. And energy is a cross-cutting theme in these next generation standards. And so we're hopeful that these are very well adopted. And a survey was done to find out what voters think of this idea of national standards. And it turns out that people are really on board with this. 84% of the people that interviewed felt extremely that new standards for science were very important or extremely important. Only 3% said that they didn't think they were important. And they also acknowledged that they thought the current science education in this country would get a C or less for most of the schools, even their local schools. So that's not good news. And but it means that there's room for improvement, right? Remember when you had a report card that would say room for improvement? We've got plenty of that. So finally, there's a lot of support for these science standards. And at National Center for Science Education, we're looking for all the tools we can to try to move the ball forward with climate education and making sure that evolution is still well taught, which is an ongoing struggle. Visit our website if you haven't seen the new climate part of our website at ncse.com/climate. And we are a member-funded organization, so if you like the work that we do, consider becoming a member. And I think with that, if there's any questions or conversation, maybe we can turn the lights on.